A very warm welcome to all learners. In today's era, capacitors are used in various ways in electrical circuits. Though all capacitors cater to the same essential requirement, there are still different capacitors form used to produce various circuit functions. In today's class, we are going to discuss basic concepts of capacitance, principle of capacitor, parallel plate capacitors, partially filled with dielectric slab as well as conducting slab. Then we will study the capacitors connected in series and parallel combination of capacitors. The fundamental use of capacitor is to store in the form of electricity. It works as a temporary battery that maintains the power supply while the power is cut off. In domestic as well as commercial appliances like batteries, fans, cameras, coolers, electronic chargers, LED lights, audio requirement, etc., the capacitors is needed also. The capacitor is widely used in computers in cases of an emergency shutdown of the system. Now, today's learning outcomes: to understand all concepts of electrical capacitance, to understand the concept of parallel plate capacitor with conducting and dielectric slabs. Another outcome is to understand the concept of series and parallel combination of capacitor. Now, dear students, you understand the concept of electrical capacitance. So, basically a capacitor is a system of two conductors separated by an insulator. You can see in the diagram there are two conductors are given over to here, and from here you can get the concept of a capacitor. The ability of capacitor to store charge, that is known as capacitance, and its capacitance that can be measured or defined by capacitance equal to charge upon potential difference, and that we can say that C equal to Q upon V, where Q and minus Q are the charges on the two conductors that you can see in the diagram, and V is the potential difference between the two conductors, and C is determined purely geometrically by the shape, size and relative position of two conductors. As we have stated, C is independent on charge and potential. The capacitance basically depends on the geometrical configuration, that is shape, size and separation of the system of two conductors. It also depends on the nature of insulators, that is dielectric, separating the two conductors. The SI unit of capacitor is farad. Then 1 farad can be defined as 1 coulomb divided by 1 volt. So, 1 farad basically is equal to 1 coulomb per volt. Dear students, a capacitor which has the fixed value that can be represented by two parallel lines, and if the capacitor having the variable value, and that can be represented by parallel line and that across to an arrow, which you can see over to here, and that is the representation of variable capacitor, and the first one is the representation of fixed capacitor. Dear students, now we will calculate capacitance of an isolated spherical conductor. For that purpose, let a charge q be placed at the center of sphere, which is assumed to be concentrated at the center. Potential at any point on the surface, that is given by V equal to Q upon 4 pi epsilon naught r, where Q is the charge which is placed at the center of sphere and r is the distance of surface from the center. Then we know that capacitance equal to charge upon potential, that is C equal to Q upon V, and when you substitute the value of V in this equation, then what you will get after the simplification, C equal to 4 pi epsilon naught R, where epsilon naught is the electrical permittivity of free space. Then what we conclude by calculating the capacitance of spherical capacitor? That first one is the capacitance of spherical conductor is directly proportional to its radius. Second one, the above equation is true for conducting spheres, hollow or solids. Third one is, if the sphere is in a medium, then C equal to 4 pi epsilon r epsilon naught and small r, that is radius of spherical surface. Then fourth one is capacitance of the earth, it is considered as isolated conducting sphere and its capacitance after substituting the values, then we get 711 microfarad. We will calculate capacitance of parallel plate capacitor. For that purpose, what we will do? We consider a parallel plate capacitor consists of two large plain parallel conducting plates separated by small distance with intervening medium vacuum. You can see here these are the two parallel plates which are separated by intervening medium vacuum, and we are assuming here both the plates are having area of cross section capital A and separated by a small distance d. Now, dear students, we will find out the capacitance of parallel plate capacitor. For that purpose, first we have to calculate electric field between the plates, and that electric field is E naught equal to sigma upon epsilon naught, but sigma equal to q upon A. Sigma is surface charge density, that is E naught equal to q upon A epsilon naught, that equation we marked as 1. After substituting the value of sigma in the expression of electric field, we will get E naught equal to q upon A epsilon naught, that we are marking the equation 1. Now, we will calculate electric potential difference between the plates, and that is V equal to E naught d. This expression you have already studied in the previous class. Now, we substitute the value of E naught from equation 1 here, then it becomes V equal to q upon A epsilon naught d. Mark this equation as equation 2. Then the capacitance of parallel plate capacitor C equal to q upon V. Now, the V value we get from equation 2 and substitute here. After simplification, we will get C equal to epsilon naught A upon d. Now, if the medium between the plates of capacitor is filled with an insulating substance like dielectric, then the electric field due to the charged plates induces a net electric dipole moment in the dielectric. This effect is called polarization, and that polarization gives rise to a field in the opposite direction. The net electric field inside the dielectric and hence potential difference between the plates is thus reduced. Consequently, the capacitance C increases because the capacitance C is inversely proportional to the potential difference, and here the potential difference reduces, that is why the capacitance C increases from its value C naught when there is no medium, that is vacuum. Now, in mathematically we can say that C equal to K C naught, where K is the dielectric constant of the insulating substance. Now, after using the concept of capacitance, we can find out capacitance of parallel plate capacitors with conducting slab between the plates. For that purpose, we consider a charged parallel plate capacitor of plate area A and plate separation small d with intervening medium, air or vacuum between the plates, and the plates are having positive and negative charges as you can see in the diagram, and you already calculated the capacitance of a capacitor with intervening medium of vacuum in the previous slide, that is C naught equal to epsilon naught A upon D. Now, dear students, we insert a conducting slab of thickness T less than D between the plates of capacitor. Then electric field now extended over the distance d minus t, because electric field inside conducting slab is 0. As a result, potential difference between the capacitor plates is reduced, that is V equal to E naught d minus t, and E naught is uniform electric field, that is sigma upon epsilon naught, and sigma is surface charge density, that is q upon A. So, finally, the potential difference between the plates, that becomes V equal to q upon epsilon naught A d minus t. Now, we calculate capacitance of parallel plate capacitor by using the formula C equal to q upon V, and here we simplify after substituting the value of V, then we will get C equal to epsilon naught A upon d minus t. After that, what we will do? We take d outside in the denominator, then we will get C equal to epsilon naught A upon d within bracket 1 minus t upon d. Then this epsilon naught A upon d, that is C naught, then that expression becomes C equal to C naught upon 1 minus t upon d. Thus, it is clear that with the introduction of conducting slab between the plates of the capacitor, the capacitance of the capacitance is increased, that is C is greater than C naught. Now, dear student, similarly we will find out capacitance of parallel plate capacitor with dielectric slab between the plates. For that purpose, again we consider charged parallel plate capacitor of plate area capital A and plate separation small d with intervening medium, air or vacuum between the plates. Then the capacitance of parallel plate capacitor of plate area A separated by small distance d with intervening medium vacuum is C naught equal to epsilon naught A upon d. Now, dear students, we insert a dielectric slab of thickness T less than d between the plates of capacitor, then the magnitude of electric field within the dielectric is E naught upon k. Since the magnitude of electric field within the dielectric is reduced, as a result potential difference between the capacitor plate is also reduced, that is V equal to E naught d minus t plus E naught upon k. From here E naught we can take common, and then expression becomes V equal to E naught d minus t plus 1 upon k. Now, V equal to sigma upon epsilon naught, that comes after substituting the value of E naught within bracket d minus t plus 1 upon k. Then substitute the value of sigma, that is q upon A, then the expression becomes V equal to q upon epsilon naught A d minus t plus 1 upon k within bracket and marked as equation 1. Now, we will calculate capacitance of parallel plate capacitor by using the formula C equal to Q upon V, and the V we have already calculated, which is given by equation 1, and substitute value here, then what you will get? C equal to epsilon naught A divided by d minus T plus T upon K. Now, C equal to epsilon naught A upon d minus T within bracket 1 minus 1 upon K. Mark this equation number 2. Thus, with the introduction of dielectric slab between the plates of the capacitor, the capacitance of the capacitor also increases, that is C greater than C naught. We will learn about the combination of capacitors. So, there are two combinations. One is capacitors are connected in series, another one is capacitors are connected in parallel. So, one by one we will study. The first we will take capacitors in series. So, for that purpose, first we have to define the capacitors are said to be connected in series if charge on each plate is the same, that is plus Q on one plate and minus Q on another plate. Consider three capacitors of capacitance C1, C2, C3 connected in series across a battery. You can see in the figure C1, C2, C3, they are connected with a battery and the charge on each plate remains the same, that is onto the one plate plus Q, another plate minus Q, but potential difference across to each capacitor is different, that is V1, V2 and then V3. So, total potential onto this combination is V equal to V1 plus V2 plus V3. Now, we substitute the value of V1, V2, V3 in terms of charge and capacitance. Then we will get V equal to Q upon C1 plus Q upon C2 plus Q upon C3. Let Cs be the equivalent capacitance of this combination, then V equal to Q upon Cs, and the value of the V that we have already calculated. Now, we substitute this value here and then after the simplification you will get Q upon Cs equal to Q upon C1 plus Q upon C2 plus Q upon C3. Now, from here you take Q common, then Q and Q get cancelled out, and final expression what you will get, that is 1 upon Cs equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. Now, we will learn the capacitors are in parallel. So, the capacitors are said to be connected in parallel if potential difference across each capacitor is the same. Now, we consider three capacitors C1, C2 and C3 connected in parallel across a battery of V volt as shown in figure. You can see here in the figure C1, C2, C3, they are connected in parallel across to a battery of potential V volt. Let Q1, Q2 and Q3 are the respective charges on capacitors. Then the total charge, that Q equal to Q1 plus Q2 plus Q3. Now, substitute the value of Q1, Q2, Q3, then what you will get? Q equal to C1V plus C2V plus C3V, and V we can take common, then it becomes V within bracket C1 plus C2 plus C3. Now, we say that Cp be the equivalent capacitance of this combination, then Q equal to Cpv, and substitute this value of Q in the previous expression, then what you will get? Cpv equal to V within bracket C1 plus C2 plus C3. Now, V and V get cancelled, then you will get Cp equal to C1 plus C2 plus C3. So, this is the final result for the capacitors connected in. Now, we will take one numerical. so that you can understand the concept of series and parallel combination of capacitors. Find the charge on 5 microfarad capacitor in the circuit as shown in the figure. Now, you see that in the figure between A and B points 3 microfarad capacitor is connected and 2 microfarad, 5 microfarad and here it is 4 microfarad, and this combination is connected with a battery or cell of 6 volt. Our aim is to find out the charge across to the capacitor 5 microfarad. So, for that purpose, first of all you have to calculate total capacitance of this combination, because this combination of 2 microfarad capacitor and 5 microfarad capacitor is connected in series with 3 microfarad capacitor, and as you know that in series charge remains constant. So, that concept you have to apply and calculate the value of total capacitance, and after that we will calculate the charge across to 5 microfarad capacitor. So, you see that the capacitance between the A and B points, by applying the formula you calculate 7 into 3 divided by 7 plus 3. Now, the question is arises from where this 7 comes. Now, you can see the diagram 2 microfarad and 5 microfarad capacitors, they are connected in parallel. So, in parallel the capacitance is C1 plus C2. So, that becomes 2 microfarad plus 5 microfarad, that becomes 7 microfarad, and then this combination is connected in series with 3 microfarad. So, that is why then you apply the formula for series combination, and in series combination 7 microfarad and 3 microfarad. For that purpose you calculate the value by applying the formula CAB equal to 7 into 3 divided by 7 plus 3, and that becomes 21 upon 10 microfarad, and this is the capacitance between the point A and B. Now, the total charge in branch AB you have to calculate, because you apply the concept, the charge in series combination is same. So, that is why we have to calculate first total charge in branch AB. So, that is Q equal to CAB into V, and CAB you have already calculated, that is 21 upon 10 and V is 6. So, 21 upon 10 multiplied by 6, and that becomes 63 upon 5 microcoulomb. Now, potential difference across to the 3 microfarad capacitor, and that becomes Q by 3, and which is equal to 63 upon 5 multiplied by 1 upon 3, then that becomes 21 upon 5 volt. Now, the potential difference across the parallel combination, and that becomes 6 minus 21 upon 5 equal to 9 upon 5 volt, and that is the potential difference across to the parallel combination. Now, charge on 5 microfarad capacitor equal to 5 into 10 is power minus 6 multiplied by 9 upon 5, then it comes 9 into 10 is power minus 6 coulomb, that is 9 microcoulomb. Now, dear learners, this is assignment for you. X and Y are two parallel capacitors having the same area of plates and same separation between the plates. X has air between the plates and Y contains dielectric medium of epsilon r equal to 5, and this combination is connected by a 12 volt battery, you can see here in diagram. Now, you have to calculate the potential difference between the plates of X and Y. Another, what is the ratio of electrostatic energy stored in X and Y. So, these two points you have to calculate in this assignment. Dear learners, now what we have learned today? we discussed electrical capacitance, we discussed spherical capacitor and its capacitance, we discussed parallel plate capacitor, then parallel plate capacitor with conducting slab, with dielectric slab. After that, we learn combination of capacitors, that is capacitors in series, capacitors are in parallel. After that, we solve one numerical in which you learn the concept of series and parallel combinations. Then I gave you say assignment, and that assignment you have to solve it in your notebook. Till then, you explore your knowledge by doing more and more problems related to the topics which you have learned today. Thank you. Have a nice day.